Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, my dear students. I hope that you might be fine at your homes. As you know that the situation is very worse as per the pandemic of coronavirus is concerned. So my dear students, our school and management had decided to provide you live classes. But sometimes in my subject there are some questions which are numerical based, which have some derivations. Therefore, it's very difficult for me to make you understand on the online. Therefore, today I thought to make a short video for you in order to make you more clear the concept. So, my dear students, today's topic is about the chapter work, power and energy. It's of class 9th. Actually, the question is very important. That is, the question is derivation of kinetic energy, that is K is equal to 1 by 2 mv square, where this m is the mass of body and v is the velocity of body. So today, my dear students, let's start this derivation, how to prove this theorem. So I may write here proof. You know that what is here term? Kinetic energy. First of all, student must know what is kinetic energy. The energy possessed by the body due to its motion is called kinetic energy. The energy possessed by the body due to its motion is called kinetic energy. For example, moving air possesses kinetic energy. Moving fan possesses kinetic energy. Moving train possesses kinetic energy. A bullet fired from the gun is example of kinetic energy. So today we have to derive its expression, how this is equal to this. So let me start. As we know that हमें पता है work done is equal to force into distance moved. This is actually the formula which we have discussed in a previous lecture. Work done is equal to force into distance moved. So I may write here, instead of work done, we can use its formula, that is, its symbol, that is W. Force की symbol है F, into distance moved is denoted by S. So we will name it as equation first. We have also discussed in chapter first, there are three equations of motion. One is V is equal to U plus AT. Second equation is S is equal to UT plus 1 by 2 AT square. And third equation is V square minus U square is equal to 2AS. We have derived these equations one by one. Out of these three equations, we have to use here this equation, because what is here? S. S is present here. We will find the value of this S, and then that value will be substituted in this equation. So I may write here, from third equation of motion, we have. What is that equation? That is V square minus U square is equal to 2AS. Here is S. We will find out the value of this S. So I may write it like this: 2 times AS is equal to V square minus U square. What I did here, I have taken this right hand side in the left hand side, and left hand side taken into right hand side. S is as it is, V square minus U square as it is. These two terms are multiplied with S. When we take this 2A with right hand side, it will be divided, because this is the rule in mathematics. It is the equation number 2nd. You know that one more equation we have learned that in chapter number 2nd, that's force and laws of motion, that is force is equal to mass into acceleration according to Newton's second law of motion. So I may write here, we also know that F is equal to m into A. From third equation of motion, we have taken the value of S, that's equal to this. So instead of this value, we can substitute in this equation this value instead of this. What is here? F. That F is given here. We will name it as equation third. Now this F is equal to m into A, and this S is equal to this. We will put equation second and equation third in equation first. So I may write here, put equation second and equation third in equation first we get. So what is here? W. Therefore W is equal to, what is here? F. That's equal to m into A. Then formula ka multiply into S. What is S? That's equal to v square minus u square divided by 2A. This acceleration and acceleration is cancelled. W is equal to m into v square minus u square divided by this 2. You know that when body is at rest, at that time its initial velocity is 0. We are discussing about kinetic energy. It means that before starting the body in motion, the body is at rest. Therefore, this u is equal to 0. I may write here, instead of this u, I will put u is equal to 0. We will name this equation 4, in equation 4. So what is this? Therefore, W is equal to m into v square minus 0 square, because u is equal to 0. On u there is a square, so here is square, divided by this 2. So W is equal to m into v square, 0 ka square 0, that's 0 divided by 2. Yeah, because I can write here 2 ones are 2. W is equal to mv square. V square subtracted with 0, that's v square divided by 2. I can write here like this. W is equal, what is here? 2. I will give you a simple example. 5 by 2. We can write it like this, 1 by 2 into 5. Because if we multiply this and this, it should be equal to this. Let us check. 5 1 is 5. Divide and divide is divide. 2 ones are 2. So I may write like this, 1 by 2 mv square. But what is here? Here is a kinetic energy, but we get here W. So we have to replace this work done. This is actually work done. We have to replace this work done with the symbol Ke. So I can write here Ke is equal to 1 by 2 mv square. Hence proved. And this is the simple derivation for kinetic energy. I hope that you might have understand this topic very easily and comfortably. In case if you have any problem in understanding, you can contact on my number. That's 962288854552. Thanks. Have a nice day.